What's up, everyone? I'm Chris.
I'm Adam.
We're with Nismia and Scuba.Tech, and today for Nismia, we're going to be unboxing and setting up the Blue Robotics Blue ROV2. We want to give thanks right up front to their immense support. They have been incredibly helpful and incredibly supportive. Today we're going to learn together just exactly what comes in the Blue ROV kit, as well as how to set it up. And by that I mean this is my first time seeing it. I have a fair amount of experience with previous ROV systems that we've been using. By our powers combined, we're going to figure this one out. Why don't you introduce yourself, Mr. Camera Operator?
Hi, I'm Josh, ROV tender, cameraman, and Nismia extraordinaire.
And certified scuba diver.
There you go, certified scuba diver.
The Blue ROV2 is a partially open source in terms of software and modular hardware ROV. It's good to about 100 meters. That's 330 feet, rated to 3 knots or 1.5 meters per second. That's quick. So it's going to be a very, very useful unit for recovering artifacts or battling currents here in our North Atlantic. And Adam, I mean, look at this. It's got a really powerful set of quad lamps. So what kind of things do you think we're going to see with these lights in this region?
Well, for starters, we're going to explore some shipwrecks. New York Harbor was a major hub for shipping for the last few hundred years. There are tons of shipwrecks from here to the Jersey Shore to Long Island.
Nice.
And we're going to be working with the Billion Oyster Project. We're going to be exploring some oyster reefs. We're also talking with the Coney Island Aquarium to try to get the Blue ROV into one of their tanks. We're basically launching this as part of the New York State Marine Education Association's program called Introduction to Northeast Marine Sciences.
The New York State Marine Education Association, or NISMIA, is a collective of teachers, professors, educators that are formal and informal, as well as, I believe, scientists, engineers, divers, anyone who wants to help with marine education, right?
Yep.
They have a really important mission.
Yeah, and so Chris, Josh, and we're divers, and so we bring the diving element in conjunction with the teachers, and so the goal here is to take all the good things that all three of us have seen and take our network and just put it on film with the Blue ROV and to get it into the local schools, primarily in underserved communities like Coney Island, just as an example. And the goal is to just, let inner city students become aware of what really lies beneath the surface in our own backyard.
We're going to be unboxing what is probably the coolest ROV on the market. Shout out to Blue Robotics, I mean that. We're then going to be taking this into the water. We're going to be messing around with underwater video. We're going to be messing around with underwater virtual reality. We're going to be doing some shipwreck and fish identification. And we're going to try to start bringing ROV dives as like a telepresence model into the classroom. These are just a preview of some of the things we're planning. There's a little more coming soon. So make sure you get subscribed if you're watching and you want to see more of that. Anything you want to add to this?
Don't forget to hit that like button.
Okay, fair enough. Should we go ahead and unbox this thing?
Yeah, let's do it.
3, 2, 1. Wow, that's beautiful. Or maybe this is holding the battery, perhaps? There's a lithium-ion battery. 15.6 amp hours. Making great progress. Next up, we have... This looks like a frame.
The reel.
This is the reel. If I had to guess, I would assume that this one is on the ROV itself, and this one is probably topside, where the spool meets the controller, but we'll find out. We're going to be assembling the spool that the tether kind of winds up on. Fittings for the spool. Notice they're all machined out of solid aluminum. Here's some more of that nice hardware that the spool comes with.
Like part.
Whoa!
Spool. It almost feels like the spool fits into here, and this is where the quick connect goes. Oh boy, box 2.
Woo! Looks like it's Christmas time here in Greenwood Lake.
The world's most affordable, high-performance ROV.
I think we found our other 3 thrusters,
Yep.
right? Wait, you know, I know. Josh, what is that?
I don't know, what is that? It's like a bunch of... Was this like a hub for something?
This is foam that's incompressible, so that this block has a given buoyancy, will not change at depth. A wetsuit compresses with depth. The buoyancy changes, you get less buoyancy with the neoprene as you go further deeper, right? This foam stays mostly the same, which means you have a known amount of buoyancy, a known amount of flotation that supports the ROV.
We want the ROV neutral at all times because we
Yeah.
want the thrusters to dictate going up and down.
If you're going to be retrieving an object that you know has some weight to it, you want to have the ROV be slightly buoyant. If you're going to be exploring and observing, you want it to be neutral. Speaking of retrieving artifacts, this is the Newton gripper. It's basically a robot arm. That looks really well built. Next up, we're unboxing a much larger acrylic enclosure. This is for the battery, most likely, and I think this larger one is where the camera, the computer, and all of the other accessories go. Oh, yeah, look at that beautiful optical dome. Look at that. It's delicate. This is so cool. This is gorgeous. Looks like we're getting to the fun accessories. Lumen Quad R4RP, 4 high brightness lights. Whoa, look at that. What are your thoughts to the quality? I mean, have you ever seen something like this at this price point?
I personally never. That's what Blue ROV is all about.
I'm starting to get that feeling. How is their service?
Impeccable, fantastic.
Fantastic.
Honestly, even a
Alright,
guy
heard it
like
from
me
him.
could figure things out with their help.
Do they have a phone number where you can talk to people?
Oh yeah,
Okay, that's kind of a
absolutely.
big deal.
Yeah.
Now, why such a big beefy battery charger? The answer is because it's a big beefy battery and you need a lot of circuitry to handle that kind of power. Important note for battery safety, especially charging lithium ion or lithium polymer, you want to make sure you have it on a non-flammable surface, ideally metal, ideally steel, and you want to make sure you're always around a battery of this size and power when it's charging. This is a heavy one. Gonna do the honors?
I believe they're little weights.
There we go. This is a vacuum pump, and we use it to check the integrity of the ROV's container, the electronics container and the battery container before the dive starts. We're basically pulling a vacuum to check that the seals are good. This frame looks very well built. It's ductile, it's flexible, which means it's not gonna crack if it ever, gets bumped or, things happen on a boat. This looks like the brackets where the thrusters and the buoyancy will attach to. We'll find out as we build it. Hey Adam, what's the most important part of the kit?
Stickers.
Stickers! Wow! What else we got? Pressure relief valve, we'll show you that. And all of the hardware needed, and this looks to all be high quality stainless steel. Blue Robotics, we're seriously impressed with what you include in your build kit. Very, very comprehensive set of components and even tools. So we're building the ROV. Now what's kind of cool here is that all of the assembly documentation is on the Blue Robotics website. The Blue ROV2 assembly guide is not just hosted on their website, which you would expect, but it is fully dynamic. So you actually select the revision you have, and then you can kind of select which configuration you have. It looks like it's walking you through step by step. I gotta say, this is some of the best laid out documentation I've ever seen. So we're ready to start building the frame.
Here in the corner because we want to keep the package.
Battery enclosure. It's pretty cool looking. We're gonna insert them. We'll see what they're getting at. Well, we got the 3-inch battery canister installed, the battery tube, and I just finished lining it up with the bracket that's on this bottom frame plate here. And then I just finished lining up the locking cord handle here so that it's centered, mounting the battery retention system. So this is the electronics enclosure, and we're going to be connecting some cables. We're going to be connecting the power supply, going to be connecting what appears to be the depth sensor, and looks like some tether and pressure reliefs. So we've just removed the 18-hole end cap, and now we're going to have the ability to install both the power pass-through as well as the pressure sensor, as well as probably the tether input and a pressure relief valve and a whole bunch of other accessories that allow the computer and the camera to work with the rest of the ROV.
Hey Josh, what do you got going on over there?
So we've got this battery management system called the H6 Pro. We have a computer right here, power cord. We have our input, battery management ribbon, and a stick of dynamite. Just gonna connect the power, good old AC input.
Cool.
So first what we're gonna do is connect the cables.
Take a look at that cable.
One right there. We got
It's a
our,
pretty hardy cable.
and then we got our management cable right here. You can either do a charge task, which will prepare it for operations later on in the day or tomorrow, or if you're planning on keeping the battery just off to the side for a while, a couple weeks, you have the storage option. You never want to select charge and then put your battery off for a long time because that will degrade the performance of the battery over a long period of time. In our case, we're going to be using it soon, so we're going to select charge and then start task.
After the day of diving is finished, we connect the batteries and we place them on the storage routine. That'll discharge and level them off at a safe voltage for extended storage. And here's the view when the storage mode is finished. As you can see, the storage discharge is complete. The intercell voltage is 3.8, which is just about perfect for storage. I am taking these EPDM and Viton O-rings and I'm applying some Moly Coat, which is basically a silicone-based grease. And I'm installing those O-rings onto the bulkhead penetrators of all of our thrusters and our lights and our battery, our power delivery leads and our robot grabber arm. And basically what that's going to let us do is have these cables to all of these accessories and drive components connect to our power circuitry inside the main chassis without letting water get in. So these are basically sealing the outside environment, protecting the inside environment.
Well, currently I'm working on doing the software installation right now. Just kind of going through the guide and seeing what I need to do. Oh, is it really that simple? Oh, no, it's not.
We're about to do the next round of Moly Coat on the O-rings. Here's the last thruster. It's labeled. That's what it looks like once it's installed, so we'll set this down. And now I'm going to do these 5 in a row, and then we're ready to start fitting everything into the main container bulkhead.
Currently we're putting together the feet for the spool, and you're using thread lock for every single thread here because this thing has to remain solid for forever.
Forever?
This is never coming apart, ever.
Listen to space chat. Ooh, looks like a winner.
Undressing some of the wiring that I've just done to tidy it all up. You see how it's all bundled, and just finished connecting our accessory power. Now I'm going to start connecting the thrusters to their respective controllers. Green to green, and then blue to blue. That's not normally guaranteed, but for this build it is, because Blue Robotics took the time to make everything match, which is an attention to detail that is greatly appreciated. So I have just matched it here to the chart. You can see the color coding. So thruster 1 is labeled 1, ESC1, and it's also color coded magenta. And you can see right here where I'm pointing with the driver, you can see the color swatch right there. If I trace the wires right on out to the bulkhead and go to the thruster to check my work, it's labeled number 1 from when we first unboxed it. There's number 5, and that's going to go to this block here. It's just that simple. Behold our main control unit. Just finished the last wire here, running some of our accessory control signaling here. This is for the LEDs and the grabber arm. Running the, right here, the I2C connection. This is going to our depth sensor. These are all the power connections for the thrusters up here. There's power and ground for the accessories. And then these are also power for the other 3 thrusters right there. So the camera here is also connected around and through to our hat on top of the Raspberry Pi as well. So the Raspberry Pi is not only getting an input to the camera as well as controlling the motor. And there's the USB, so that's the camera input, and then that's the camera control. It's also controlling the accessories, the lights and the grabber arm. The Raspberry Pi is also controlling via pulse width modulation our ESCs, which drive our thrusters. And then the Raspberry Pi is talking via this network interface here to our Fathom tether interface, and that's taking the tether wires and turning it into a network socket that the Raspberry Pi can talk to. Go ahead and get this cased up, get it connected to the power module, and do a vacuum test. I just finished building the battery housing end cap and harness, and now we're going to loosely assemble everything into place, and we're going to do a vacuum test to make sure all the O-rings are absolutely perfect. We're going to hook up our vacuum pump along with our vacuum gauge. We're going to pump both of these canisters down to a partial vacuum. Then we're going to do a decay test. We're going to see how long it takes or if the vacuum recovers. So here's what the full assembly looks like. Here's our vacuum pump. We're going to pump it down to a partial vacuum. With the magic of this manifold just put together, it's going to pump down the battery chamber and the electronics housing. 15 inches of mercury or 50 kPa of vacuum. And we're going to make sure that decay time is better than 10 minutes, meaning longer than 10 minutes. Gonna start pumping away. Well, it has been 10 minutes, and as you can see, we're right within tolerance. I have been positioning the thrusters in their, their respective slots and routing all the cable. And I'm just now torquing everything to spec. In order to prevent, the surge or lifting from pulling directly on the tether and damaging where it's mounted, the tether's wrapping around this composite thimble. It's going to get zipped right here with these, and then it's going to get secured right here, so that any strong tugs on the tether, whether that's from crew or sea surge, are transmitted through here directly to the frame and don't tug on this fragile bulkhead. So we've just installed the arm. We can have it fully extended for use in diving, and then when we want to put this back in the crate, we can pull it back right to about there. The cabling set up so that it's avoiding the blast from this thruster and this thruster. Everything's nice and flush and tight, including the rear. We want to make sure that we eliminate flutter and resonance, so we've got all the bundles nice and tightly managed there as well. And just like that, after, I don't know, what, 20 hours of work between the three of us? More. It's done, and it's beautiful. Oh.
Yeah, it's great.
Gorgeous.
Everything we'd hoped for, and more.
Okay, so Josh here has just finished charging the battery and brought it over, and we're ready to install it in the ROV now, so we can program the controller and so we can get ready to dive. And the way we're going to install the battery is we're going to remove the bulkhead cap right here on this lower chamber, this lower pressure chamber. We're going to slide the battery in and we're going to hook up the wiring. Before we do any of this, we need to make sure that the ROV is safe to rotate onto its front so we can get to the rear where the battery goes. To do so, we need to retract the grabber arm if you have that installed. And the way we're going to get to it is really simple. Around the side here, there's a nice little clamp release. Going to turn that to loosen. Going to slide the arm clear. Then we're going to retighten. And what this has done is it's made the entire ROV safe to rest on its front. Lift it up so we don't crush the lights that are on the bottom quadrants, and then we rest it on the frame. All the weight is resting on the side rails. So we're ready to install the battery. We've made the front safe to rest on the side rails. So we're going to take off this bulkhead here. The first thing we're going to do is remove the retaining ring. Going to grab that, pull it right out. Then you're going to use this as leverage. You're going to rest your hands down like this, and you're going to push up while alternating. If it doesn't readily come out, you might have a slight pressure delta holding it in. So we're going to make sure that we ventilate the pressure release valve to allow any vacuum to be relieved. We're going to gently wiggle it out. And we're going to make sure that we keep the seals clean. We're going to just let it hang around the side and over the top like that, where the seals mate. We're going to make sure we keep that clean as well. We're going to try to reduce the amount of time this is left open so that dust doesn't settle on it. To place the battery, all we're going to do is gently set it in, bring the top cap on round, and connect the power leads. So now that we've connected the power leads, we're going to fold them down nice and gently out of the way, and we're going to place that bulkhead right down on top and gently alternate pressure. We want to make sure that this tab here aligns with the slot. So once the bulkhead cap is down into place, we're checking the two main O-ring seals to make sure we have a good sealing surface all the way around. I'm going to take that retaining ring and we're going to thread it right back into place. Now you may be wondering, what orientation? Does it go in this way or this way? The truth is it doesn't matter, but it's nice to make it match the top just so it looks good. It should go in very, very freely. If it doesn't, it means that your cap is not aligned or it's not in all the way. Battery's now connected and we're ready to power up. Okay, so now we're calibrating the sensors, and we're going to do that with the 90-degree rolling orientation steps here.
It's having us holding the ROV in the current orientation until these sensors are calibrated, and we're going to press next. That's completed. So now we're going to take the ROV, rotate it 90 degrees. The port is going to be facing the ground.
Confirmed, it's matching, port to ground, and we're going to hit next. Accelerometer calibration complete. Now we're going to reboot our vehicle to take the changes. When it boots and takes that as the straight and level position. Raspberry Pi. Manual flight mode.
I am, take a look, setting up IP address for the computer to talk to the ROV. Now, it's basically a large Ethernet cable that connects to the interface management system right here. Goes 330 feet down under the ocean, plugs into the ROV, and receives and transmits signals. And right now, it requires a dedicated IP address and subnet mask, which are all right here.
Right.
We have to set up to allow us to do that.
We're going to calibrate the compass next. Getting the magnetic sensing elements in here, I guess, aligned with the magnetic flux of where we are. And so to do that, I have to rotate it around the X, Y, and Z axes respectively. So we just finished this one. Now we're going to rotate it this way while I watch the progress bar and make sure it's happy.
Watch as the progress bar increases as he moves the ROV around.
And now we will transition about the Z axis. All right, cool. Good.
Calibration complete.
All right, what's it showing? We're in a good place now to start doing our training dives. Hey everyone, so we're at the pool ready to dive. Now it's time to connect the battery. We already transported it with it in the canister, so let's plug everything in. The battery plug looks like, there you go. We're gonna release the pressure. Whole setup is locked and ready to go.
The ROV is connected to the Fathom X tether, all 330 feet of it, American units, then connected to the Blue Robotics interface right here, which is then connected via USB-B to the computer, which is now powering up, which then comes out via USB-C cable to our wonderful Xbox controller. So I currently just started up the Blue OS front end. This is just the operating system on the ROV itself, and currently I'm also starting up Q Ground Control, which is the software used to command the ROV. We're just going to check all the settings, make sure everything's calibrated. We're going to go through the measurement units page. We're going to make sure everything is in feet and imperial system, and then from there, when we determine everything's correct, we're going to check if the camera feed is live.
Connected the battery, we've sealed everything up, we've extended the arm, we've powered up the main controller unit, and we've installed the weights. And it's time to check buoyancy and trim. So with the arm extended, we're going to insert it into the pool. Let's see how it settles. That seems pretty neutral to me.
Yeah.
And the trim, if you can see, it's port up, starboard down, slightly nose down. You can kind of see the orientation right out the box with that. And the reason for that, you could see here that the manipulator arm being extended is creating a moment arm or a lever of this extra weight, tipping it nose down, and since the weight is mounted here, it's leaning over that way a bit. Instead of moving this one to here, we're simply going to add one here. We're going to accomplish two things. We're going to get that bias set for salt water, and we're going to fix the lean. Let's give it a shot. So we expect this ROV to be negatively buoyant ever so slightly, and that's okay. So this is our operations log, which also serves as a checklist. So we fill it out as we go, and at the end of the day of diving, we also have a log entry ready to go for us. It's available at Scuba.Tech. We're going to customize this to work with the blue ROV2. So there's going to be some extra lines added that are specific to the unit that we're working with. ROV battery is charged to 100%. Controller battery is charged to 100%. That's the laptop, by the way. Our ballast is installed with the preliminary load of 5 blocks. Mission divers have been briefed. That's myself and Josh today. We know what the plan is. We're going to place it in the water with the thrusters off and see how it is buoyant and how it trims. We have our entanglement operational risk management plan. There is one entanglement hazard. If you point the camera around, you can see here we've got a pool cleaner going. We're also going to make sure that the manipulator is extended and locked. So we're going to unlock the manipulator arm bracket, going to extend it, and then we're going to relock it. Coming to the rear of the unit, we're going to make sure that the pressure regulator valve caps are closed and fully locked down. We're also going to make sure that all of the bulkhead penetrators remain finger tight. And then finally, we're going to make sure that all 4 of the retention clips remain in for the ballast end caps. We're expecting it to be slightly negative now. Perfect trim, slightly negative. It doesn't get better than that. And to be clear, slightly negative is good because we're in freshwater and we will be diving in saltwater. So this will be neutral in saltwater or perhaps slightly positive. Both are great. How do we retrieve it when it's down there? Just gently pull it up by the tether until the grab handle is exposed. Pull it out by the grab handle. That would be, I guess, our first successful unpowered dive. We went to 3 feet and back. Okay, Josh, commander to pilot, start the pre-dive check.
Got it. We are switching to manual now.
Okay, bringing it in.
Got it. I'm going to arm the ROV. All clear of thrusters.
Stand by. Thrusters clear.
Armed.
Confirm armed.
ROV is confirmed armed. So we're going to check to make sure that the thrusters work. Notice we're going to check the forward and reverse stick to make sure that the forward and reverse thrusters are still working.
Thrusters are clear, good for check.
Forward,
Forward good,
back.
aft good.
All right, gonna check vertical, up,
Good,
down.
good.
All right, check complete. Disarming the ROV.
Confirm disarm.
Disarmed.
Cool.
Disarm confirmed.
All right, it's 3 hours later. Long story short, we're gonna have a test dive and then we're gonna get the camera working and then I think we're ready for the actual first dive, right? All right, so without further ado, arming the ROV now.
Armed.
ROV is armed, tether is clear. Thruster chest. Forward, aft. Translate port. Translate starboard. Vertical, up. Vertical, down. Lights.
Camera action.
She goes. Stabilizer works, turning on depth hold. Depth hold engaged. Now that we know that the depth hold function works. Arming now. Tether clear?
Tether clear.
Okay, in the water. Okay, looking good.
She's floating. She's driving.
Nice, nice. Look at that. Got good yaw control. We got good depth control. We got forward and aft. We have good lateral translation. This is great. It's driving a bit smoother now. So you can see my translational controls now. So I'm going to go ahead and motor away from the camera. And with that, I'm going to call it a provisionally successful first dive. We have no camera system, so we were doing the dive with line of sight. We're going to go ahead and retrieve the ROV and put everything away. And we will work on the pilot station and video feeds throughout the upcoming week to get ready for the first operational dive trip. It's going to be fun.
Okay, we're good. I'm here at the YMCA of Greater Monmouth County, who have generously allowed us to use their pool. I'm here with my brother Michael, who will be operating the tether, and our cameraman, Jesse, aboard the tether. I'm gonna do the thing. And so we packed the ROV up, knowing she was fully operational and ready to go.